Hi everybody, this is Mr. Bowman, and in this video we're going to focus on area and volume. So let's get started with this particular problem. It is a calculator OK problem. It says let R be the region enclosed by the graph of f of x equals x to the fourth minus 2.3x cubed plus 4. So that's going to be f of x here. And the horizontal line y is equal to 4, as shown in the figure above. Find the volume of the solid generated when R is rotated about the horizontal line, y is equal to -2. Alright, so to help you visualize this, I've redrawn f of x and y is equal to 4, along with the line y is equal to -2, which this is going to be rotated about. So, since this is going to be rotated, I think the easiest way to get an idea of what this looks like is to draw a reflection over the image up there over the line y is equal to -2, and that's about the best I can do there. And when you rotate, you are going to create circular cross sections, and there's going to be two circles that are formed here. One is the outer circle and one is the inner circle. So we're going to have this washer here, which I'm going to shade in yellow. And we basically need to find an area function for that. So our area function is going to be the big radius. We'll call that big R, pi times big R squared. So A of x, it's a function of x because we're rotating it around a horizontal axis. We're integrating with respect to x. Is going to be pi times big R squared minus pi times little r squared, r squared. So we can factor out the pi if we want. Big R is going to be 4 minus -2, or 6 squared, minus little r is going to be f of x minus -2 quantity squared. So we're going to do a little bit of simplifying here. This is going to be pi times 6 squared minus f of x minus 2 quantity squared. And to find the volume, we're going to have to integrate that starting at 0. We'll find the upper limit in just a minute. So a of x dx. Now the upper limit is the next point of intersection of these two, which is right here. And if you put both f of x and y equal 4 into your calculator, you will find that those two intersect at x is equal to 2.3. So we're going to integrate from 0 to 2.3. And if you go ahead and you integrate that, you get approximately 98.868 for your answer. And there we go. There is a answer. 2 points for the integrand, 1 for the limits, and 1 for the answer. Be careful. Don't make the same mistake that I made. Subtracting a negative there becomes a positive. So make sure you make that a positive. The next part of this question says, region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with leg R. Find the volume of the solid. So to illustrate what that looks like, you basically have an isosceles right triangle like this. Not doing a very good job of graphing that, so let me redo that. Isosceles right triangle. Those two are congruent to each other, and that's our isosceles right triangle. So we need to find an area function for that. A of x again, and A of x is going to be 1/2 times one base times the other base. And one base is 4 minus f of x, and we're going to square that. So the volume for part B is the integral from 0 to 2.3 of a of x dx. And I said y is equal to 4, but I meant to write that down. And that would give us our answer. And our answer would be approximately 3.574. And again, not only do you have to show this work, but you actually have to plug this into your calculator and integrate that. And for the last part, we are going to have to find a vertical line x is equal to k that divides region R into two regions with equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. So to illustrate that, I'm going to erase this triangle we have, and we're going to draw in a line where we think k might be. So k is about right there. X is equal to k, where we think the green area is approximately, or is equal to, the blue area. Okay? So we need to find an answer for, or an equation, an integral equation for how to solve that. So basically what we have is we have the integral from 0 to k of 4 minus f of x dx is equal to the integral from k to, remember we said that that x value right there was 2.3. So k to 2.3 of 4 minus f of x dx. So let's take a look at the scoring rubrics for parts B and C. The integral from 0 to 2.3 of this is basically our a of x dx, and we get 2 points for the integrand and 1 point for the answer. Notice, even if you can just set up the integrand, you get lots of points for that, even if you don't have time to calculate it. And for the last one, the integral from 0 to k of 4 minus f of x dx is equal to the integral from k to 2.3 of 4 minus x dx. Area of one region for 1 point and 1 point for the equation.